Hey everybody, I wanted to spend a little bit of time talking to you about molality, which is going to lead into some colligative property discussion. But before we get into the fun colligative property things, we need to talk about molality. And so molality is used, I don't want to say exclusively, but for the kind of the casual chemist, molality is pretty much used just when we're talking about colligative properties. And so molality is an alternative way of expressing concentration that eliminates temperature dependence of the concentration. So if you think about molarity is moles per liter, and remember that liter can change based on temperature. You heat up a liquid, it expands, it gets bigger, and those sorts of things happen. So by using molality, we are eliminating the temperature dependence of concentration. Now, molality, like molality is the units is called molal. Okay, it's kind of a weird thing. When you get into higher level chemistry, you hear and see weird names. So molal is the word that we use to describe something with a molality. And this is the formula, and the symbol for molality is lowercase m, which is interesting because lowercase m already is defined as something as mass, so it's interesting that they use that. Sometimes it'll be a script m, or a funny looking m to indicate it. Notice how this one has like little tails on it, okay? So that we can identify molality versus, let's say, a mass, okay? And so molality is moles of solute per kilograms of solvent. Solute meaning the thing that is dissolved into the water, and solvent is usually water. Could be other things, but typically water. So it's moles per kilogram. Okay, so here's our sample problem where we have antifreeze. And this is really good because antifreeze, the way that the method of action of antifreeze is a colligative property, that as we add something to water, it lowers the freezing point dramatically, or could be dramatically. So anyways, here's the molality. So it says, suppose we have 1.2 kilograms of antifreeze, which is ethylene glycol, with this formula is added to a radiator that contains 4 kilograms of water. It says, what is the molality of the resulting solution? Okay, so let me call up my calculator. And so I'm going to start by writing the formula that I need. Okay, let me back up. It's moles of solute versus kilograms of solvent. Okay, so it's moles of solute over kilograms of solvent. Well, here, water is our solvent, so we already have 4.0 kilograms of H2O. Okay, great. But now we need to go to moles of antifreeze, because that's going to be our solute. So we need to now know our conversions into moles. So, well, we have to use the molar mass, and we also have to convert this number into grams. So that's 1,200 grams, and then we are going to set up our X line, grams on the bottom, moles on the top. And what is the molar mass of this? Well, of ethylene glycol, let's see, how many hydrogens do we have? We have 1, 3, 5, 6, and that's times about 1. And then how many oxygens do we have? We have 2 times about 16, and then we have carbon, which is 2 times about 12. So we do, in order to find the molar mass, we do 6 times 1 plus 2 times 16 plus 2 times 12. And so that molar mass here is 62. And the units are the thing that are going to tell us what we do here. That's 62 grams for every 1 mole. Or if you're going to write this as a as a conversion factor, it's 62 grams equals 1 mole. Okay, and so now what number goes with grams? 62 grams. What number goes with moles? That. So when we're converting to moles, we do 1200, and then we divide by 62. Okay, we get an answer of 19.4 moles. Okay, now here's our, we now take this, and now that we have it written down, we can go here. Okay, and so we do moles of solute, so the molality, I'll do a funny M, equals moles, which is 19.4, divided by 4 kilograms of water, okay, and that equals, so 19.4 divided by 4 equals about 4.85, and then molal. The unit can just be a regular M. So that is the molality. Molality tells us, again, it's another unit of concentration, tells us the concentration. Okay, and it's temperature independent. So there we go. That is a sample problem of molality that introduces the idea of molality, and have a great day.